motivation is the current status of smart contract is still in the current status of smart contract in the construction industry. Currently, smart contracts are useful in process automation, data security, solving trust issue, and so on. However, therefore, they are more and more common in the construction industry. However, application and uses are still in the conceptual level, which make and many theoretical frameworks are proposed as proof of concept. Moreover, current smart contracts are programming code, which is difficult to read by non-programmer stakeholders like lawyers for contracting, clients, and contractors. Currently, the smart contract logic need to be developed by stakeholders, but the actual implementation need to be done by programmer. In this way, the generation procedure of smart contract is complex, manual, and error-prone. Therefore, the method of generating smart contract from graphical representations had many benefits for stakeholders and researchers. First, graphical representations are visual and human readable. Stakeholders and researchers can easily develop their logic using them. As an automated and efficient procedure, it's easy to check and verify and reduce human efforts. In this paper, the selected graphical representation is called YAVO, yet another workflow language, which is a graphical workflow in XML-based format for business processes. In this YAVO example, there are 4 tasks. After starting, execute the submit request task. After finish, the approve request task is an all split task, which will either go to accept task or reject task, and then end. The selected smart contract language is called Solidity, which is a well-known smart contract language from Ethereum blockchain. In this Solidity example, there are a contract called migrations is defined as with 2 state variables, 1 modifier, 1 constructor, and 1 function. The modifier is used to restrict that only the sender should be the owner, and the function called set completed is a public function with the restrictive modifier, which is for setting a value to the last complete migration state variables. The framework overview is showing in the figure, which is for visually generating and verifying smart contract. There are 4 steps in this generator. First, parse an XML from XML format file and translate it into a smart contract language, and then check the correctness of the generated smart contract, and then in the end export them. The most important step are translation and checking step. In this paper, I would have a detailed explanation from YAVO to Solidity. The translation step is showing in this figure, which is extracting the YAVO file and YAVO raw file into the Solidity file. The extracted information is shown in the middle, and the Solidity components are showing in the left, in the right. In the YAVO file, a type called action type is defined in this paper to distinguish different action types of a task. In this method, 3 actions are defined called view, modify, and pay. The information extracted from the YAVO will be translated as Solidity. So in here, the local variable, task, roles, and process flow will be extracted from YAVO. And for example, the local variable will be translated as state variable. The tasks will be translated as function, and one role like a contractor or a client will be translated as one state variable and one modifier. And modifier are used in this example to restrict that only the specific role can execute specific function. The process flows are used to tell the running order of the execute of the tasks. The translating YAML information will be separated into two solidity files. The make contract name is obtained from the YAML name, and another file contract called SC process flow contract, which is to restrict the running order of the function based on the process flow. The checking rules of the Solidity smart contract language is showing in this figure. A checking rule are defined for verifying the correctness of the generated smart contract. The defined checking rules are mainly checking for one grammatical error. For example, the name should be unique and valid. The type should be existed or defined. And two, irregular behavior. For example, the function defined in the make contract, the statement should be generated based on the action type like view, modifier, or pay. For more information of the checking step, you can see the paper. A YAML example is showing in this figure. A building unit is defined to store the bill or quantity information of a group or construction work. In this example, it shows the construction process of a building unit. There are 2 rows and 8 tasks are defined. So first, the contractor will start a building unit. Once complete, it will report it, and the client would check the defect in this building unit. Once everything is perfect, then the building unit will be paid automatically, and then the process will be end. If they are defeated, then the building unit will be divided into building unit complete and a building unit redefined. So the building unit complete will be paid automatically. The building unit defeat will be redefined by the client. And once the contractor agree with this building unit redefined, and then the whole process will be restart again. If the contractor disagree with this building BUD, then the whole process will be ended. Now I will explain the implemented smart contract generator. In this, the part A in this part are the parse and translate step. Part B is the check and export step. In the part A1, a graphical YAML representation is loaded and showing. In part A2, the corresponding YAML rows file is loaded and showing. After clicking the From Graphical to Smart Contract button, the corresponding smart contract file with the 3 folders and the text will be showing in A3. After clicking the smart contract checking button, a checking table with error messages will be showing in the part B. And after clicking the thank you. After clicking the export smart contract button, the contract folder with 2 smart contract files will be exported. Since this method is designed for stakeholder and researchers, the first next step will be asking the user to use it. Instead of using it as a desktop application, it will be more useful to develop it as a plugin, which can be easily integrated into other applications. In the translation steps, only 5 components are considered. However, there are more components in Solidity, like mapping, event, abstract contract, and so on. more checking rules, more other graphical representations, and other smart contract language should be considered in the future. In this paper, we only consider translating from graphical representation to smart contract. However, another direction should also be considered, which is from smart contract languages to XML or graphical representations. Thank you so much for your attention.
Thank you. Thanks a lot. We have a question from the audience. It's like, thanks for your presentation. I am not clear what information you represent.